All right, we're starting our unit on geometry and we're going to be doing area of parallelograms. So this is a mini lesson on how to find the area of a parallelogram. So the area is, we use a different formula in terms of words for area of parallelograms than rectangles and squares. So in a rectangle, we do length times width. In a parallelogram, we use the word base and height, and that's because we've got some slanted pieces that aren't right angles. So here's an example of a parallelogram, and our height can be shown on the outside or it can be shown on the inside of a parallelogram, but it's always denoted with this right angle piece, if you can see that here. And the base is always the bottom side or the two that are laying flat. Now, why is that? Is we decompose our parallelogram. And so if we take this piece off and we had scissors and we cut this piece off right here, okay, we've got this little triangle here. If we move this guy over to this side, he will magically fit and now become our rectangle. So this shape has been decomposed from this parallelogram right here, but it has the same area because we didn't take anything away. We just took off the piece and reassembled it over here to look like a shape that we already know how to do. So in this two examples, I've got two different parallelograms, one that's laying a little flat and the other is laying tall, but they have the same exact properties in terms of what's going on. So in this parallelogram, I've got three pieces that have been marked. I've got my base, my height, and I've got the length of this side piece. Now, if you look up here at this example, we do not use this piece at all. It's actually inside. So if I took this off and reassembled it over here, that 15 no longer exists in my shape. So again, this is where my right angle is. So that is the only piece that I need to worry about, those two pieces where that makes that right angle. So if I take the 12 times the 20, base times height, I get the area of this parallelogram, which is 240 centimeters squared. Okay, so that 15 never ever came into play. I would only use it if I wanted to find perimeter of my parallelogram, but I'm going to find area, and area is always where that right angle piece is. All right, so let's look at example 2. Again, I have my three pieces labeled. I have my base, my height, and then the length of this parallelogram. Again, if I took scissors and cut this triangle piece off, glued it over here, that 11 no longer exists. So where that right angle is that 4 and the 9. Those are the two pieces that make that right angle. Okay, so there's one and there's the other. So for this parallelogram, we have 4 times 9, and that's 36 inches squared. So, whoops, there we go. All right, so I have my 36 inches squared on that one. The 11 does not come into play whatsoever. And that is how you find the area of a parallelogram.